Hi, third graders. It's Ms. Jaramillo, and we're going to check our DMA for today. So we're going to take a look at our problems for today. Please make sure you're coming back each day and double checking your DMA solutions on your video. So we want to make sure that you're retaining these skills and reviewing these skills every week. So number one, we're going to look at our first set of problems. We have 30 times 2, which means you have 30 groups of 2. Or we could use our order property and say, let's switch the factors and make it easier for ourselves and say 2 groups of 30. Well, what does that mean, 2 groups of 30? So instead of counting 30 groups of 2, I'm just going to say I understand this as repeated addition. And I know that it's going to be 30 plus 30. If I were to show it on as base 10 blocks, I could take 2 groups of 30. So I've got my base 10 blocks here. Here's a group of 30. And I have another group of 30. And whenever I have 30 and 30, just like 3 plus 3, 3 ones and 3 ones would be 6 ones. Well, here I have 3 tens and 3 tens, and that makes 6 tens, which is 60. So those 6 tens are going to be my product for 2 groups of 30, which is 60. Now my next problem is 30 times 3. And again, I'm just going to take my understanding and just switch my factors, and now I've got 30 groups of 30 instead of 30 groups of 3. So now I can take, using what I understand about the distributive property, and I know that 2 groups of 30 is going to give me 60 because I already used that. And now I'm going to take and add another group of 30. So these 2 groups of 30 made 60, and now I'm going to add one more group of 30, and that's going to give me 60, 70, 80, and 90. So 3 groups of 30, or if I said 3 plus 3 is 6, and 3 plus 3 is 9, if I was using ones, now I know these are tens. This would be 30. Oops, actually, I wanted to show you using the distributive property. So I'm going to take 2 groups of 30, and I'm going to add one more group of 30 on to that. So I know that 2 groups of 30 is 60, plus another group of 30 is going to give me 90. Or I could add 30 plus 30 plus 30. So I'm showing that repeated addition with my multiplication. So the next problem, same thing. We're taking these 30 groups of 4, and instead we're going to switch our factors. Since we've already been working with 30s, let's do 4 groups of 30. So I already knew what 2 groups of 30 was. So now I'm just going to take and put another 2 groups of 30, since that's what I already have on my model here for my base 10 blocks. So I'm just going to take these 3 groups of 30 and add another 1 group of 30. Or, like I just said, you could have 2 groups of 30 and 2 groups of 30. So this could actually be 3 groups of 30 and 1 more group of 30. Or we've got 2 groups of 30 here. Notice how I have 2 groups of 30 here and another 2 groups of 30 here. So now that I know that 3 groups of 30 is 90, I could say 100, 110, 120. Now, just like you know 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, 3 groups of 30 is going to be 120. So that is so this would be 60, and this would be 60, and 60 and 60 is going to give you 120. So that's using our understanding of the distributive property to help us use what 4 times 30 is. So here's 2 groups and 2 groups, and that makes 4 groups of 30. Let's take a look at our rounding problem. It asks us to round each number to its nearest 10. So I'm going to look at my tens place. I always want to find my tens place because my hundreds place isn't going to change unless this is 90s. Unless we have 90s here in our tens place, the likelihood of that changing our hundreds place is very slim. So unless these were 90s, we are not going to have to worry about our hundreds place rounding up at all. So 678, we're going to round that number to the nearest 10. Remember, we're rounding to the nearest 10, so we're looking at our tens place. So if I take my multiples of 10 chart and I look for the number 678, I know that 678 would be right around here between 670, which is in my tens place, 70, and 680. So remember, the hundreds place does not fall off. It's still there. We just know that we have 670, and the next 10 would be 680. And I'm showing this like you would see on a number line. Now, remember, 675 is right in the middle. So make sure that you're paying attention to that ones place and the 5. So since 678 is going to be maybe right around here, 678, you're going to be closer to 680 because we're past the 5 in the ones place. So it's past 675, so we're going to round up to 680. Now, same thing for 179. 170 is going to be our first 10 because the 70 is in the tens place here, and the next 10 is going to be 80. So we have the 2 tens that it's between is 170 and 180. Again, using your multiples of 10 chart, I know that that's going to be right about here. So 170 and 180. The rest of the tens are still there. We just are pinpointing where 179 is going to be. And remember, 175 is always going to be in your middle. We round to the closest tens. These are my tens. 5 is not a 10. These are my tens. So we know that 179 is 1 away from 180. It's 9 away from 170, so it's closer to 180. So now we're going to take and add these 2 rounded amounts. Remember, this is not the exact sum that we're finding. This is the estimated sum. It's about, when I go to add these together, it's going to be about close to this amount here. So 600 plus 100, 600 plus 100 is 700. And 80 and 80, if I take 2 tens, which is 20, and add it to 80, that's 100. That leaves me here with 60. So I add that, and 100, and 80 is going to be 160. I put that together, and I'm going to have 860. That's my rounded estimate. Now, if I wanted to know the exact sum of 678 and 179, I could take 678 and add to it 179. I can line up my place values. So 9 and 8, 8 plus 8, if you know 8 plus 8, you're using your doubles. A doubles plus 1 would be 8 plus 8 is 16. 1 more would be 17. That 10 from the 17 gets carried, and now I have 1 more 10 to add here. So 70 and 70 is 140, plus 1 more 10 is 150. Now, a lot of people might say, well, you have 15 here. 15, but 15 what? 15 tens. And 15 tens is 150. And I'm going to carry that 100 to the hundreds place, and I have 600 plus 7, 100 is 700 plus one more 100 is 800. So this is 857. That is pretty close to 860. So we know that we've estimated correctly, and it's pretty close to our exact sum. We also have some simpler one digit by one digit two-factor equations here. So 1 factor, 2 factors, 5 groups of 0. So again, I don't care how many groups of 0 I could add together, it's always going to be 0. Even if I had 200 times 0, 200 times 0 would be 0. 1 group of 4, how much is that total? 4. 6 groups of 7, or 6 times 7, 6 groups of 7, I could break this apart as 3 groups of 7 and another 3 groups of 7. Remember that this and means that you're putting them together. So if I were to show this as an array, I'd have 6 rows, and I'm splitting it here, and I have 7 in each row. So I could fill these all in with 7 objects in each row. Now, why do we use the distributive property? It's so that we don't have to sit and count every single one of these little counters that I'm drawing in here in my array. It's going to be easier for me to say 7 plus 7 plus 7 is 21. And if these 3 rows of 7 should also be 21. And 20 and 20 is 40, and 1 and 1 is 2. So I have 42. So I'm doubling my 3's. I'm doubling my 3 to make 6, and I can double 3 times 7 to give me 6 times 7. And finally, we have our word problem. So our word problem says, Ingrid is watching 2 spiders crawling on the sidewalk. The fuzzy spider crawls 3 times as far as the brown spider. Now this is where we've talked about times as multiplication using the word times, not time like on a clock. So 3 times as far. So we're going to show this using a bar diagram in just a moment. The brown spider crawls 4 feet. How many feet does the fuzzy spider crawl? So again, she's watching 2 spiders. She's watching the fuzzy spider that crawls 3 times as far as the brown spider. And the brown spider crawls 4 feet. So I'm going to draw this for myself, thinking about the information that I have, because they want to know how far the fuzzy spider has crawled. So we know that the brown spider has crawled 4 feet. And I'm just going to label this, and I'm going to put brown next to it. This is just going to help me visualize what's happening here. Now I'm going to, next to the brown spider, I'm going to draw how far the fuzzy spider is going to crawl. And it says fuzzy spider crawls 3 times as far. So one time he goes 4 feet. 2 times he crawls another 4 feet. And 3 times he crawls another 4 feet. So I'm just drawing this for myself to give me more of a visual of what's happening. 3 times as far. Now, if fuzzy spider crawls 3 times as far than brown spider, we know that there's a difference between those 2 spiders. So 4 plus 4 is 8, plus 4 is 12. So we are doing 3 groups of 4, and 3 times 4 is going to be 12. Now, this 3, we said times, right? Well, the times here is the groups, right? 3 times. So we're saying 4, we have 4 3 times. A lot of you guys think of it this way, but really it's the times that we're saying this number, okay? So these are the times, and these are the 4 feet each time, or each group, if that makes sense. And this is going to be my total feet for the fuzzy spider. So now I can come back here and I could say fuzzy spider, actually let's do it on my paper here. Fuzzy spider crawls 12 feet. Oh, not spiders, we're not plural, just one. Fuzzy spider crawls 12 feet since I drew brown spider at 4 feet, and then, right? And then I drew 4 feet 3 times for fuzzy spider. I drew 4 feet 3 times. So that's in my group. That's how far he drew, or he crawled each time. So I drew 4 feet 3 times and added 4 plus 4 plus 4, and this is what I'm doing. I'm proving this. I'm proving that this 12 feet is how I can figure this out. So I added 4 plus 4 plus 4, or I multiplied 3 groups of 4. 3 groups of 4. So I'm proving what I'm doing here by saying what I did. Okay, so those are our DMA examples for today. So this is my equation, 3 times, and it's 4 feet each time, and that gives me 12 total feet. Again, remember, multiplication is looking for the total. Now that we're looking at division, we're taking the total and breaking it up. That's not what's happening here. We're looking for the total. How many feet does this fuzzy spider crawl? So be careful with that. All right, come back tomorrow and we will be going over our DMA week 14, day 2. Have a great afternoon, guys, and we'll see you soon.